In this video, we're going to go over sets in Python. So sets are an unordered collection of data without duplicates. And so right here we have an example. It's just, we have curly braces and we have different pieces of data passed in. And you'll notice there's no 5, 5, 6 because that would be a duplicate, and sets do not allow for duplicates. We can have any type of data. We can have a string if we wanted to. In this case though, we're just using numbers. And these sets also support any sort of mathematical operations that you can do on sets. So if you're familiar with things like unions, intersections, differences, and whatever else, you can do all those on sets as well. Some basic uses of sets usually include things like membership testing and eliminating duplicates. So we had a list that contained a bunch of numbers. We could say we had a bunch of duplicates. We could then get a set. In this case would be like 1, 2, and 3. So we could remove all our duplicates by converting a list into a set. Let's go ahead and go over how to create sets and how to use them. So I'll go ahead and delete all of this. And then down here, we can go ahead and get started. So first things first, to create a set, we can create a variable. So set this equal to some curly braces. And then we can do just 1, 2, 3, 4, 5, and 6. To get the set we have in our example there. And that's one way to create a set, but we can go ahead and do this another way as well. So what we can do here is do another test set. This will equal set, and then in parentheses here, we can pass in a bunch of different things, with a bunch of B's, a bunch of C's, a bunch of C's, and then we'll see what we get here. Let's go ahead and print test set, and then print another test set. Like that. Then we'll open up the terminal here and we will run Python 3, and this file is called tutorial.py. And then you see here what we get is we get our set of numbers, and it looks exactly the same because in this set over here, there's no duplicates. And then when we created the set with the set keyword, or with the set function here, what we're doing is we're taking the string and we're breaking the characters up into a set. And since no duplicates are allowed, all we're getting is A, B, and C. You'll notice here that this came in a different order. This is because sets are an unordered data structure, so we can't really determine the order, and so they could come back in any order. In this case, it is CBA. And so that's an important thing to note, that if you need it to be in a specific order, sets will not work for you. But that's how we create sets. We could also go ahead and create an empty set, and that will be just with the set keyword with nothing passed in. And then if we go ahead and print that as well down here, and we come back here, we'll get just our empty set back. Now, it's important to note though, if we do this, and do empty curly braces to try to create an empty set with this sort of syntax, this will not work. This is no longer a set. This is now a dictionary. So if we print this out, we'll get just an empty dictionary back, but this is not a set. To create an empty set, you need to use just the set keyword. So important thing there just to kind of point out in case you run into issues trying to create empty sets. Okay, so that works pretty well there. That's how we can create sets using the different keywords. Now let's go ahead and check to see if an item is inside of a set. So I'm going to go ahead and create a new set here. So do sports equals, and I'll just use the curly brace syntax for now. We'll add some different sports in here. We'll add rugby, and then we'll add baseball. And then to check if a sport is in our sports set here, what we can do is we'll print the result out, and we'll do football in sports. And we can also do another one. And we'll do, let's say like lacrosse or something that's not inside of here in sports. So this first one will return true because this string is inside of our sports set, and this one will return false because it's not inside of our sports set. We save that, we come back here, we run this, then you get true and false just like that. So we can check if something's inside of a set with this in keyword. Now let's go ahead and go over some of the different mathematical functions we can call on sets. So I'm going to create two sets, set 1, and this will be, let's do a 1, 2, and 3, and then we'll do a set 2, and this will be 1, 2, 3, 4, 5, 6, 7, 8. So let's start with a set union. And actually, to start, just to show how this works, let's add a 0 to start on this set, and I'll delete that here in a second. But let's go ahead and do a set union first. So we'll do union equals set.union, pass in set 1 and set 2. And I'll see what this returns. So we come in here. First, I guess I should print the union. And you'll see what this returns. This should take the two sets and combine them together. So we'll come here and we'll go ahead and run this. And we get 0, 1, 2, 3, 4, 5, 6, 7, 8. So it did take them and it combined them all into one set. And of course, since this has some overlap, 1, 2, and 3, and this had 1, 2, and 3 as well, we're not including duplicates. So all it is doing is taking the 0 and creating a new set with 0 included within this set. Is all it's really doing there. So union just combines the two sets together and returns all of the elements. Now, let's go ahead and look at a intersection. So do intersection equals set. We'll pick a set. This time we'll do set 1 dot intersection, and then we'll do set 2. So now let's see what elements intersect with what elements in set 1 intersect with elements in set 2. So we go ahead and print our intersection. We'll come back here and we'll run this. Now we're getting 1, 2, and 3, and that's because 0 is not in both sets, 1 is, 2 is, and 3 is. So it's returning 1, 2, and 3 in its own set. Okay, and then we can keep going from here, and we can look at a difference. We can do a difference equals set 1 dot difference, set 2, and then we can go ahead and print this out as well. And now the difference being only 0. And why is that? That's because this is doing the opposite. We're checking to see if it's not in the other set. So we're taking the element in set 1 and checking if the element is not in set 2. 0 is not in set 2, so it returns that. And 1 is, 2 is, and 3 is. So all it's doing is returning just the 0 element. Or just the 0 value within the set. Okay. Now for this next example, we're going to look at subsets and supersets. So to do this, I'm going to go ahead and delete the 0. And that way we have a subset. So a subset will just be like 1, 2, and 3 is part of this set here. So it's a subset of set 2. And set 2 is a superset of set 1 because it does include those within it, if that makes sense. So let's go look through some examples in case that's not very familiar. So we'll do is subset equals set 1, and then we can do less than equal to set 2, and that's how we check if it's a subset. We'll do a print is subset, and it go back true because 1, 2, and 3 is a subset of 1, 2, 3, 4, 5, 6, 7, 8 because this is included within this set, so it is a subset. And then we can also do the opposite, which is superset, and we'll check if set well, first we'll do set 1 greater than or equal to set 2. So we'll check if it's a superset of set 2. And we'll come back here and we'll run that and we'll get false. I'll comment this out so we don't have to see this. We got false though because set 1 is not a superset of set 2. Set 2 is a superset of set 1. So we can go ahead and switch these around. Set 2 and then set 1. Come here and we'll run this, and that is true because this is contained inside of this. So set 2 is a superset of set 1. Okay, and from there we can keep going and we can do some other operations on the sets that kind of do the same as we did here, but just a different way of writing it. So for example, we could print out set 1 minus set 2. And then we look at this here. It returned an empty set because taking the there's no difference between these two sets. If we added in like a 0 here and then we did this, we then return the 0 because 0 is not included in this other set. We could then check what elements are in both sets by printing out set 1 and then doing the OR. So it's kind of similar to other things you'll see here. We're kind of subtracting out the elements that are the same. This one we're doing the OR to check if it's in one or the other. And then when we go ahead and print out this, we're getting all of our elements because we're checking if they're in either or of the sets. So we're just kind of doing a union there on both of these two sets here. From there, we can go ahead and check for an intersection using the AND character. So we're checking if it's in both set 1 and in set 2. So we can do set 1 and set 2, and then check what elements are in both sets. In this case, we get 1, 2, and 3, as those are common across both of our sets. And then finally, we can do if it's in A or B, but not both. So we can do print set 1, and then do that little character there, and then do set 2. And this will check if it's in one or the other, but not both of them. And we get 0, 4, 5, 6, 7, or 8. So those are just a few ways to go ahead and interact with our sets and determine these different things. If you're familiar with set theory, hopefully that made sense. If not, hopefully at least these at the end did. All we're doing is just doing some basic operations on the set to get the difference between the sets, combining both sets, combining sets, or getting all the elements that are the same in both sets, and then getting the ones that are not in both. And so it just gives you different ways to interact with the sets for whatever you need to do. The last thing I like to do here is go over set comprehensions. So just like we have list comprehensions and we have dictionary comprehensions, we also have set comprehensions. So let's go ahead and I'm going to go over the example that's in the Python documentation and kind of walk through that to show how this works. So what we can do is create a set. In this case, we'll call it A. And then we can create a set with our curly braces. And we'll do X for X in, and a string here, abracadabra, if X not in ABC. So what we're doing here is we're creating this variable X, and we're going over every character in abracadabra, the string here, and setting that character to the variable X. And then we're checking if X is not in ABC. So if the character is not equal to A, or it's not equal to B, or it's not equal to C, then we're going to go ahead and add it to the set. But we also don't allow for duplicates because it's a set. So it's going to check A, B, R, A, C all the way through here and just get the unique characters that are not A, B, or C. So we'll get R and D, I guess, would be the two returns. And it will only return both of those once because we don't allow for duplicates. Let's go ahead and print out this set and take a look at it. And we get D and R. And of course, this order, you can't determine the order because there's no order to sets. So it could come back in either order. In this case, it's going D and R. And that is how we use set comprehensions to create more complicated sets based off some sort of condition that we set within the comprehension. Hopefully that all made sense. If not, let me know and I'll try to explain it a little bit more. But that is really it. I just want to go over a quick video going over sets and how to use them in Python. It's something that's not used nearly as often, but it's still good to know and how to interact with them in case you ever need to use sets within your code. All of the code will be in the description below. Thank you for watching, and I hope to see you in the next video.